and then go up to page 25. Almost halfway. Yep. And we only have 1 day left. So you have,
Halfway to the halfway point.
yeah. So I'll be talking really fast and just
type really fast.
yes. I don't have to write anything. In fact, nope. Okay, we left off yesterday with a tip speed. So no stories, I guess. Tip speed is a principal limiting factor in prop efficiency. Is a principal limiting factor for prop efficiency. And I told you because tips, yeah, you start going to transonic, you get all kinds of problem. Excessive speed, meaning getting close to the speed of sound, causes flutter and vibration.
Is flutter just when it kind of...
Any little heart flutters when you see your girlfriend? It's the same thing. Flutter is an unbelievable thing. I've got to find this video. I can't do it right now. But you talk about balancing control surfaces on aircraft. You guys had Phil, right? You probably talked about. Okay, so you'll do more of that in second year. But it's critical to the balance, and it doesn't make sense. It's like I don't understand. It's a fixed piece of aluminum or whatever, and you got a rod going to it, and you think you can just make it go up and down, but yet it's got to be perfectly balanced. If it doesn't, it can get into this flutter. And you hear that, and you're like, whatever, I don't know what the flutter is. And then I saw a movie one time where they were at, NASA or somebody was doing flutter tests on an aircraft. It's the most bizarre thing you've ever seen. And so they've got this camera facing back on the tail of an aircraft, and it just starts doing this, and it's almost like a wave going back and forth. You think, I don't even know how the metal does that. You're watching it, and then it just accelerates, and it starts to break off the airplane. They pull back or whatever, stop it. But it's crazy to see when metal starts fluttering.
So like resonant frequency kind of?
Yep, so you can get resonant frequency, vibration, and literal flutter.
And then it just...
departs. You get a hub depart light, as they say. So tip speed must be below speed of sound. Tip speed must be below speed of sound, which is 746 miles per hour, pH at sea level. And I would say, not only that, you can't go right up to that. Oh, 744, I'll be fine. 745, pushing your luck. No, you can't go transonic. You got to be below that. So D, all right. So to prevent tips from going supersonic or just too fast, what are some things we can do to solve that? RPM. Okay, limit RPM. Definitely limit RPM. 2, shorten blades. Or reduction gear. Very good. Spin the engine faster, turn the prop slower. Some of this stuff, it's like, I don't know why I bring it up, but it's actually things that kind of stick in my head when I'm working around props, and I kind of like it. Propeller load. Obviously, the faster the prop turns, the more power it absorbs, which is kind of what you just said. Or uses.
What do you mean by it absorbs?
The engine is the horsepower. It's putting it out, so it's going to the prop.
Okay.
So it's absorbing that. And we could say absorbs. Obviously, it's going to transfer it into thrust.
Yeah.
But this particular source used that term. But this is varies with the cube of RPM. So that works out to, if you double the RPM, you get 8 times the power. Absorb. A lot. 80% of horsepower is used for thrust. Horsepower is used or converted to thrust, which means that 20% for friction and slippage.
What do you mean by double the RPM 8 times?
So if you went from 1,000 RPM to 2,000 RPM, the propeller is going to have to absorb 8 times the amount of power. Power is the wrong word because the engine didn't go 8 times the power.
Yeah.
Its workload goes up 8 times. How about that?
So how much it?
Yeah. No, from like 1,000 to 2,000.
So from 1,000 to 2,000, it would multiply the thrust it outputs by 8,
I would.
or just cube,
I don't know.
or the.
Maybe I shouldn't have put this up here. You guys are fixating on it. I don't have the answer for you. I'm sorry. It's like, oh, I just thought that was just a neat little gee whiz kind of bit of information. But now that we try and dissect it, can't really answer that. I simply wrote varies with the cube. The faster the propeller turns, the more power it absorbs or uses. So it varies with the cube of the RPM. In other words, double the RPM equals 8 times the power required. And that's all I got written there.
Okay, I guess it makes sense.
Sometimes I don't always understand what I say. It's one of those cases.
I guess it kind of makes sense.
Seems pretty straightforward.
Efficiency. All right. Thrust horsepower. I won't belay this point because I have a bunch of statements on this. We'll just keep this one simple. Thrust horsepower is the actual amount of horsepower that the engine propeller unit transforms into thrust. The actual amount of horsepower that an engine propeller unit transforms into thrust. So if we go back to talking about horsepower from last semester, right, we had theoretical horsepower, then we had brake horsepower,
Brake horsepower.
and the brake horsepower is what you get at the prop flange actual. That was your theoretical minus your friction equals brake horsepower. Take the brake horsepower, add the prop on. How efficient the prop is, you get your thrust horsepower. Put it all together. All right, so some of you have had Aero 300, some have not. So some of you this will be review, some not. Asymmetric loading. Asymmetric. What is asymmetric loading of a propeller? What's that?
This is more lift than the other. More thrust.
P factor. The P stands for
Prop.
pucker.
Makes you pucker.
Power?
It's the pucker factor.
Prop factor.
Prop factor. I guess. I never heard it defined. I would just assume it's prop
I think
factor.
that's what Phil said was prop factor.
Then we'll call it that. All right. So in straight, this would be so much easier if we actually had an airplane sitting here on its tail. But I'll tell you this story. So in England, because it's on the other side of the equator, that's not true. Yes, I wasn't even going to let it go. Because they're on the other side of the hemisphere, their engines turn the other way, right? Just like when you cross the equator, your toilet goes the other way. That's true.
Well, the toilet part,
I
yeah.
really don't think that the engines spin the other way.
They do spin the other way.
But it's because they
No,
built
it's
them.
all right.
But it's because they built them that way.
Yeah.
They built them.
So,
There's a boat there.
Are
Yeah.
they still talking about it, that they have to like adjust for that when they're flying?
okay, so British engines did in fact turn to the left, or did, or whatever.
Oh, this is just blowing my mind.
Yeah, it's just the way they built them. You know, it's just like helicopters, right? European helicopters turn the other way too. Yeah. Okay.
No, that either.
So anyway, so this guy, he's a RAF pilot. You know, flew in the war, thousands and thousands of hours, and should I back up the story? When you take off in a tail-wheeled airplane, you have gyroscopic precession. So you have this big disc, right? And gyroscopic precession says that whenever you put an input, it's going to happen 90 degrees later. So their engines are spinning to the left. And you have to think of this big disc of the prop. And when you raise the tail up, it's like you pushed on the prop right here to get it up,
And
the tail up.
it would
So
be-
the disc goes this way. So it's like
Oh,
pushing it
okay.
here. So you're pushing the prop here to bring the tail up,
and you-
right? So if I'm pushing it here, but the
It's
prop's
felt
going that
90
way,
degrees up.
it's like I grabbed this prop tip and just pulled really hard this way. So that's any tail-wheeled aircraft. When you bring the tail up, that's why you have to have a tail-wheel endorsement, because you can't go out and fly a tail-wheeled airplane, because you got to be aware of this stuff. So what happens? That tail comes up. So you got to be ready, and you got to give it right rudder, and then you give it left and right, and left, and a little right and a little left, and you just dance on them until it's time to go. But anyway, it's really important that you bring in that right rudder to keep the airplane from going off that way. Well, so I had a friend slash customer who had a Piper Pacer, which is a tail-wheeled aircraft. And so he was going to let his friend, with all of these hours, fly it. But a Pacer is a tail-wheeled aircraft, and our engines turn to the right. So when you bring the tail up, it wants to go
to the left.
hard left. So you better be ready on that right rudder. So this poor RAF pilot, he takes off on this airplane. He brings it up. And he's thinking, I gotta be ready on the rudder. So he did. He brought it up and gave it some nice left rudder.
Incorrect rudder.
And that thing just went hard right out into the mud and flipped over on its back. That way. Right?
Yep.
Everybody picture the runways going? He went over there in the mud. Off that way. And the reason I'm doing that is because that's an easy way to remember which way the airplane wants to go. Over there. Our planes. So you got to give a little bit of right rudder to keep it from doing that. So I can just visualize that day like it was yesterday, going picking the airplane up so it's upside down. So so not only do we have that, but we have P factor. So I didn't write the stuff about the gyroscopic precession in my notes. I just thought about it. So with P factor, the reason why I bring this up, not because we're pilots, because you have to realize that when an airplane is straight and level, and you have the blades, the twist of the blades, and if it's straight and perfectly level, you can go on the 75% station, wherever you want, on this blade, on this side, and measure the angle. And then you can go right over to this side, you can measure the angle, and the two will be exactly the same, because it's straight and level. But make a climb, and one side is going to flatten out, and the other side is going to get more of a pronounced bite, right? So which side is which?
The downward swinging blade is going to have the higher angle of attack.
Yes, it's the right side.
Gonna have-
Right side has the higher
Yeah.
angle of attack.
It's going to want to pull you away.
So think about that in a couple ways. So from a pilot's perspective, you got a bigger bite over on this side, so the plane's going to want to go.
Left.
So you lower right rudder again. So it wants to go that way. All right, but from a mechanic's standpoint, which is where you really got to focus your thoughts on, is that if you're trying to adjust blade angles or measure blade angles on any sort of propeller, if that engine or aircraft is sitting at anything other than perfectly level, then the two sides aren't going to be the same. You can't just take a protractor and go, well, zero it out and go, well, look at that. That's got quite a bite. And come over here and go, well, this one's totally flat. Well, we'll fix this one. We'll make this one the same as that one over there. And then by the time the plane is level, you got this mismatched blade angle. So that's why I bring up P factor, is just to remind you that on this side of the airplane, when the tail goes down, the angle of attack is going to increase, and on this side, it's going to decrease. Yeah.
So you say that we can't just get like a protractor like we were using, like the universal protractor, and zero it out?
You can if you use a universal propeller protractor
If you use the
and
correct-
zero it out on a reference angle.
Yeah.
But if you just used a protractor and said, well, let's reference it to the table.
Yeah.
Table's flat. We'll just make that zero, and then you walk up to a prop that's the engine's
Yeah.
sitting like it's not going to work. So you have to zero it out with a zero reference angle. So what I'm talking about is zero reference angle, and that's one of the things you're going to do is you're going to adjust the ground adjustable propeller that we have, and it is sitting at an angle. And so you have to take that into consideration. So with the protractor, you have to figure out what is zero, what is neutral, right? And there's really only one thing on the engine that is absolutely zero in line with perpendicular to the hub of the prop, which is crankshaft. So you have to check it against the crankshaft. And I'll get into that when the time comes. Okay, P factor, so at straight and level flight. Straight and level flight. Both blades, or all blades, guess I'm assuming it's a two-bladed, both blades have the same angle of attack in a climb. The downward blade which is the right side, has a higher angle of attack. Then the upward. I need to write that. This creates asymmetrical pull. And aircraft will yaw to the left. So right rudder is needed. So add right rudder. Add right rudder.
Is yours a tail wheel?
Mm-mm. Nope, I have a 182. Tail wheel versions are the 180 and 185. Yeah,
Is this similar?
you behind the pole.
Is this similar to adverse yaw, or is that more of a torque thing?
No, adverse yaw is completely different. Adverse yaw is when you're in a turn and you drop the right aileron, let's say, and you lift up the left to make it turn this way.
Yeah.
Okay, because you added lift, drag is a function of lift, so there becomes more drag on this wing that you want to go that way. And so it tends to scoot the plane around kind of funny. So it banks, but yet it twists funny, so you add rudder to bring it back in.
Okay.
Yeah.
Is that asymmetrical pull, or this creates asymmetrical? Like, is it
Asymmetrical, not symmetrical. One word, asymmetrical. Prop clearances. These are actually Q&A questions, if I remember correctly. I want to say, was this come out of part 23? Oh, yeah. 23.925 to be exact. But what's funny is part 23 has had a lot of changes that I've found. And what? No, okay. Far too often I'll be mentioning something about, part 23, and then it's like not even there anymore. They're really getting away from this exact rulemaking about this is exactly how the prop must be. And that's part 23, how to make airplanes, right? And it's getting more along the lines of, well, manufacturer, you figure it out and show us that it works, and if it works, it's fine. And in fact, I'm going to forget what it is. Like Icon, you guys familiar with that plane Icon that they make up at?
Yeah.
Those are sweet, huh? So those are light sport, and they're not made under FARs. They're made under, I forget what the initials are. It's like SAE type, but it's not. I forget what it is. Maybe it is. Remember?
It's SLEA. SLSA.
No, no, it's actually it's a common thing that's an automotive thing. So,
That's a lot.
Yeah, I know
Huh?
what you're talking about.
That's a lot.
no, it's like SAE, Society of Automotive Engineers, but it's not. It's something similar to that. I forgot what it is. Just skip my brain.
Aviation.
No, it's actually
But it
ISO, like ISO or something like that. Okay, but it's not those two. I can't remember what it is off the top of my head. Sorry, but it's more of a standard on how you create things. That's overarching about cars, motorcycles, boat. I mean, it's all of this now. And so as long as you're making it to these standards, then you're fine, which is why legally with these airplanes, you can go to the hardware store and get an SAE grade bolt, 8 bolt, because that's the standard that they're using. Instead of FAA standards where you have to have an approved PMA part. They're completely away from this now. Now, your legacy aircraft, Cessna, Piper, we don't fall under that, but these new airplanes, these light sports, they absolutely do. You gonna look up that for me?
I'll get it eventually.
Thanks, I'd appreciate that
I know
actually.
what you're talking about. I just can't think.
I'd like to remember because it's fascinating that that's the way it is. Let me make this bigger because it could be.
Oh.
Magic, I know, look at that. So under part 23 we do have, and I know these are on the Q&As, maybe not yours, but I know it's in the Q&As. That's why I bring it up. You have to have certain clearances. Prop clearance. Well, you have to have why do you want proper clearance here?
So you don't hit your blade.
Yes, that constitutes a prop strike. Did I even tell you what what is the definition of a prop strike?
Hitting your prop on something.
No. Well, then I prop strike my airplane the other day because I bonked my head on it.
Kevin,
Thanks for not saying anything when I did that too.
ASTM.
Yeah.
ASTM.
Oh, it is ASTM. That was the first thing that came to mind. I'm like, no, it can't be ASTM. Right there. Which stands for?
Yeah, I don't know.
Society
I
of
don't know.
Testing Materials. American Society of Testing Materials. NDT thing. Yeah, because they kept thinking, no, that's NDT. All right, so
Scraping your
no, okay, when I got into the industry, this is why we're behind because I'm telling you these names. When I got in the industry, a prop strike was kind of left up to you. There was no actual definition. It was just, well, you hit your prop. Well, it's prop strike. And so what we did back then is 4313 back then, you'd take a dial indicator and you'd see if it was bent. If it wasn't bent, it's fine. Put it back together. And I don't know, it was late 90s, early 2000s, Continental Lycoming kind of came out and got wise to that and said, okay, if the propeller must be removed from the aircraft for repair, that's a prop strike. That really tightened it up a lot. So if it's just a little nick, something you can dress out, it is fine. If you're taking it off and sending it to the prop shop, you got a prop strike. So, yeah.
What do you mean by dressing?
Then you put a little clothes on it. what you guys are going to do, take a file, and clean up any nicks and dings. Yeah, that's what I'm addressing.
If you took it off to dress it, would that then?
Yeah, technically. I don't know. You're kind of splitting hairs there.
Yeah.
It's like, why did you? Well, no. So if I took a look at my prop and I thought, I got a couple little scratches and some nicks and some dings, and they're all within what an A&P is allowed to do, and it's all within the manual, and there's no problem. But, I'm going to do this, and I want to paint it, and I don't want to tape off my whole aircraft, and I don't want overspray on my aircraft. It's easier to take it off, go over here, and do that and paint it, put it back on. No, that's not a prop strike. That's just ease of. But if you're,
Ease of maintenance,
yeah,
yeah.
or if I said, a couple nicks, dings, scratches, I don't want to do it. I think I'm just going to send it to the prop shop. Okay, that's just routine maintenance. That's, it may have been one ding too many for you. It's time to get some maintenance done. But no, you bent it, smacked a tip, got to shorten it. That's prop strike. So, all right. So tail-wheeled aircraft in the flying position or the level position, you want 9 inches. Oh, there it is. Like, what's going on? 9 inches. Typical tricycle aircraft, you want 7 inches. There's more to it than that. It's got to be with the, I'll get into that, whether or not the strut's deflated, normal position. 18 inches on the water. Because water does a lot of damage to props. A lot. Told you about rain. This is what kills me. As long as you got a good inch there.
It's not. It probably won't hit the.
Fine.
It probably won't hit it.
Watch out for the stretch.
Yeah. And half an inch from other components.
Jesus.
That's
That's
So if that's an inch, is that like a 2-inch prop loader?
Is that a what?
Is that like a 2-inch prop loader?
Yeah. Yep. 2 scale. All right. Prop clearances. Let's see. Well, proper clearance is necessary. Is required. 23.925. Why? Will prevent prop damage. Reduce aerodynamic interference. On a tricycle geared aircraft. Jeez. Tricycle gear aircraft. Hey, by the way, if I said a conventional geared aircraft, what does that look like?
tricycle.
What came first?
Tailwheel.
That's conventional. Let's see, tricycle gear minimum of 7 inches between tip and ground. That is at taxi takeoff, taxi takeoff position, with gear statically deflected. Deflected.
Why is gear statically deflated?
Yeah.
Static deflection is simply the amount that a spring compresses under the weight of the equipment.
So on suspension.
Let's say normal compression. Of gear at normal weight. Is that okay?
Yeah.
So well, I have spring, most tricycle gear, they have spring gear, like Cessnas, they have spring gear in the back and then an air oil strut on the front. And it says, oh, you know, when you, the air oil strut should be, you know, 4 inches. Okay, so it's 4 inches, and I do all the maintenance, it's 4 inches. And then, okay, then I load up me and 3 of you guys, and, you know, you take your box of rocks and your dog with you, and, you know, it just gets heavier and heavier and heavier. Well, that's still, as long as I haven't exceeded my gross weight, then it's just normal static deflection. And at that point, it's going to compress a little bit. I still need to have 7 inches. But that's under normal taxi takeoff. You can throw in another caveat here, only positive clearance. Only positive clearance is required with strut deflated or critical tire blown. Strut deflated or critical.
So positive clearance suggests that it clears the ground.
Yep. As long as it missed the ground, you did it. Critical tire blown means a tire that makes the situation worse. So if one of the main tires blows and the ass end sinks down, the prop goes up, then that's not a critical tire. So in a tricycle gear with the 1 engine up front, what's the critical tire?
The 2 front gear. Or the 2
Yeah, the 2 front gears. Yeah, it's yeah. Or if we think about the Skymaster with the engine in the back, with the back engine, which one? That'd be a back one. Well, if you're just talking about the back engine, it'd be the main. But that thing is so far up there anyway. The prop is so short, it was not. That's a little prop. Tail wheel. Type aircraft. That's a minimum of 9 inches. At taxi / takeoff. Position. With gear deflected. Whichever is worse or least. Well, that's kind of a weird statement, right? Whichever is least. Because in a tail-wheeled aircraft, the taxi and takeoff positions are 2 different things. In a tail wheel, the taxi takeoff is the same. Right? You're on all 3 gear when you're taxiing to all 3 wheels. You taxi and you go to take off. You got the power. You're still on all 3 wheels. Then you pull back and go. But if you're in a tail-wheeled airplane, you're going to taxi like this. And when you take off, you're going to bring up the tail. Most of the time, unless it's a soft field, then you just take off that way. But you bring up the tail onto the mains, which brings the nose down. So if that, whichever is least. So it's either this way or this way, whichever is least. Follow?
Yes. Does that say deflected?
Yeah,
And then up there it says deflated?
deflected,
Positive clearance with strut.
deflated.
Deflated.
I'll try and write nicer. Seaplane. And I keep making things 2 words and it should be 1. But that's 18 inches between tips and water. That was easy. Structural clearances. So it's 1 inch radially between tips and structure. Like, for example, the picture where the tip came right next to the fuselage. As long as you got a good solid inch, you're fine. By the way, do you guys, when you fly on commercial planes, you think about where you sit?
A little bit.
Yeah, like on a jet, where do you sit?
I'm trying to
to sit by the wing, by the exit.
By the
Sit
wing.
right by
Yep.
that turbine, so when it explodes.
I know.
you're
I
out
want to
first.
sit right behind the engines. I don't like being in line with the turbine, anything rotating, and over the box spars or the spars of the wing. That's where I like to sit. Yeah, if I'm taking something with props, I do not want to be in line with that prop.
No.
That's a
Because,
little big.
you know, you think, oh, what are the odds of it breaking coming? Oh, yeah, rather better. Yeah, it happens. What's that?
He said he sits where he sees.
Half an inch longitudinally between blades or cuffs and stationary parts. I'll just put stationary parts. Like the wheel or the cowling or something like that. And all others is positive clearance. Between other parts. Such as spinner, other part prop spinner. Yeah, or cowling or something like that. You should probably throw cowling in there. I don't know. All right, this will be easy section here. Types of prop configurations. So basically we've got, I don't know, 2, 3. We have the tractor propeller, tractor style, where that is the prop mounted on front. Got the pusher, prop mounted in the rear. There's some downsides to that. I don't know how many downsides to the tractor. I guess that's why there's so many. More susceptible to rock damage. Rocks kick up from the rear, from the wheels. Will kick it up into the prop, or spray from water.
In a pusher?
Mm-hmm. Yeah, and that they're usually mounted higher for that reason. All right, got your tractor type. And to represent the tractor type is a
Air tractor.
air tractor. So it's prop on the front, typical.
Oh, there we go.
Yeah.
That looks like the thing from Minions.
Oh, yeah.
Looks like Grusenfield.
Oh,
You know what else it looks like to me? It kind of looks like a VW bus.
yes, it does.
It does.
It
Yeah,
does.
that's how I picked out. But anyway, so the prop's usually mounted up higher. Well, it's mounted up higher for a couple of reasons. One, because you got to have this boom here. But if you take, like, example, the Skymaster,
You have a twin.
aha, this engine is just mounted a lot higher. I don't know if that was by design or accident, or well, it wasn't an accident. It was obviously by design, but I don't know if it was just the thought, hey, we got to get the prop up higher, or if it's just it worked out better to have the way the fuselage is shaped and everything to get it up higher, which is what I think it is. Technically, I guess this would not be a Skymaster, a Cessna 337. It would be in, anybody know?
I forget the designation.
O2?
O2A.
O2? Yeah, they actually, the first of these was a 336, had fixed gear.
Interesting.
Yeah, then they
That
made the
also looks a
337.
little weird.
What?
That also looks a little goofy.
No, it just looks like one of those flying around with gear down. Pusher, and then the, obviously, by the slides, push-pull. All right. Types of props. Pictures first. Right here, push-pull.
Yeah.
Oh.
This one's pulling, this one's pushing.
Yeah, okay.
The Dornier as well.
Is it quicker? Quite a bit quicker? Or
No, it's a twin engine with symmetrical thrust. So if you lose an engine, you don't have this asymmetrical thrust issue. It's still in line.
Okay.
But no, I like the Skymasters. Even as a mechanic, I think they're cool. They're a pain in the butt to work on. They've got some serious issues. One of the problems I feel with them is that they're only running Lycoming IO 360s, which is, I don't know, what, 160 some horsepower? And so that's a big plane to be running around on 160 horsepower. So my understanding, not having piloted one, I've flown in them, but if you lose an engine,
You're struggling.
you're struggling. I guess they do okay, but the thing with Cessna gear, the way they come up is they turn and they create massive amounts of drag before they go on the wheel well. So if you lose an engine and you're sinking and you decide I'm going to lift the gear up, you're going to sink even faster. The other problem with these is in a regular twin, you run the throttle simultaneously for takeoff. And they came out with, I believe, is an AD on this to placard it. If you do this in the Skymaster, you can't see the rear engine. And you won't feel the asymmetrical thrust. You will just roll down the runway and take off on single, and you clear the end of the runway and you're not climbing. So they want you to lead with the rear. Bring the rear engine up, get your thrust going, then bring up your second. You should have increased thrust.
Interesting.
Yeah. All right, types of props. You can write this down. Fixed pitch. It is obviously a rigid propeller. Blades do not adjust, obviously, unless you got a cigarette and a big machine. Got that? Next, we have the ground adjustable propeller. The blade angles can be adjusted on the ground with proper tools. I suppose if you try hard enough, you could do it in the air. You have giant clamps right here, so 3 really. This counts as a clamp because it clamps the 2 hub halves together. You have a clamp here and a clamp there, and if you release that bolt, this bolt, and this clamp, you can adjust the blade pitch. So that would allow you to adjust your pitch for your mission. So I remember one time we had a customer with a Stearman, and they were doing this freedom flight where they had to fly from here to New York in the Stearman, which are not fast planes at all. And they wanted to get there as quick as they could, so we put the maximum amount of blade angle that we could on the prop and sent them off on the way. Then when they came back, we put it back in more towards a flat pitch so they could have better performance. Yeah.
Can you just repeat your 2 notes for the fixed pitch that you written?
Rigid propeller. Blades do not adjust. I'm gonna have to repeat this one too, huh?
No.
Okay. It's like always a page behind me. It's like, I don't know, how'd you ever say, Kevin? Because, all right, so that one. Well, then we have a 2-position propeller. Hey, remember yesterday I told you about centrifugal twisting force is the greatest amount of force, and it's always going to make the blades go to what angle?
Flat.
Flat. Unless you have counterweights. So those counterweights are going to want to drop down, and when they drop down, sorry, they're going to want to go the other way. My bad.
You want to go
Whoa.
backwards?
With centrifugal.
They don't want to roll in line to here. They want to roll backwards,
Centrifugal
so they're
wants to
here.
pull 'em
Follow? What's that?
back. Centrifugal wants to pull them back, yes? Or
Yeah,
Into the plane of rotation.
into the plane of rotation. Does everybody follow that?
Yeah.
Okay, so it's going to go this way, into the plane of rotation. Not towards here in line with the hub. You know, that's going to be out this way. It's not going to do that. It's going to want to go. So when it does that, and it rolls backwards, guess which way it rolls this?
Take a bigger bite.
Towards
It's a
feather.
yeah.
Yep, towards feather. So whenever you see counterweights, it's the opposite. All right, so I said 2-position prop allows the prop to be in either, you writing this down? Low angle for takeoff or climb, or high angle for cruise. and there's a lever in the cockpit, we'll talk about this next week, where you just go high pitch, low pitch.
And it's changeable in flight, or-
Yeah, absolutely.
So
Yep, pilot controlled, in
is that-
flight.
Is that oil operated?
We'll talk about it next week, but it is. Oil and counterweight, always. All right, and then we'll do, let me see. Oh, controllable, then we have controllable pitch. So we have the two position, everybody's on that? So I'm on D, controllable pitch, got that? Controllable pitch. Pilot can control the pitch of the blades. So it's not constant speed, it's not two positions. Two position, the blade's are going to go all the way to one stop, all the way to the other. You can't go in between. It's this or that.
What are the names of the positions?
High pitch, low pitch. Then we have the controllable pitch propeller. And we'll talk about how this works next week. But it's this one you can see is done by a little electric motor. And so the pilot has a little toggle switch in the cockpit. You get more pitch, or less pitch. And it turns this little gear and this pinion on this gear. And that rotates. When it rotates, it goes into the hub and it makes the blades go. So the pilot has control. A little more pitch, a little more pitch, a little more pitch. Right? It's not constant speed, but the pilot can at least select the pitch. And it'd be infinitely variable between the stops, between high and low. This is a Beach Roby propeller, by the way. Again, next week stuff. Then there was the one that's I'm just going to tell you I'm irritated right now. We had one of these around here. Somebody walked off with it.
What?
Yeah. This is an automatic pitch. Automatic pitch. 100% automatic. You cannot control it as the pilot. It senses what you're up to. So if it has low airspeed and high RPM, it's going to go into a flat pitch. High airspeed, medium RPM, it will go into a cruise. So it automatically adjusts it. And we'll look at it next week. But it does that by centrifugal force and angle of attack. Then there is the constant speed. It uses a hydraulic governor to automatically control blade angle. Uses hydraulic governor to automatically control blade angle. How you doing?
Yeah, I'm trying to figure out your low pitch, high pitch though. Did you say,
We'll come
I
back
thought I
to
heard you
next
said
week.
low angle, high angle, low pitch, low angle. low
Same thing.
pitch.
Maybe I said angle, maybe I said pitch. Same words.
At first you said angle, and afterwards you said pitch.
Manual control mode, where you can have a lever?
Kind of. Depends on what you're trying to control.
The-
The RPM?
Okay.
Yes, absolutely the RPM, but not the angles.
Gotcha.
All right, so where am I at? Pilot sets the RPM, and blade angle changes to hold the RPM. So I can't control what the blade angles are doing. I can control what the RPM is. So if I set it for 2100 RPM, and I pull back, the blades are going to go to a lower blade angle to allow the engine to speed up. Well, because it would tend to slow down, but it'll bring the blade angles back a little bit to keep the engine right at 2100 RPM. If I start diving for the ground, it's going to start taking big old bites trying to keep it from overspeeding. So it'll keep it right there at that 2100 throughout the range of the flight until I tell it to do something else. Till I want a different RPM. Again, this is like next week's. We have options with these. We'll cover them. We have the feathering prop, which you talked about feathering. It's a constant speed prop with that option on it. Let's see. Oh, I'll back up one. Not only do you have feathering, but you may also have a prop with a beta range. Beta range. Beta range is anything from an absolute flat pitch to reverse pitch. So you can back up. It wasn't made for backing up. It's for stopping. Now, it's not real common to see a beta range in piston engine aircraft. They are out there. I have worked on them. I had one of my favorite customers had a Baron. I don't know if he was my favorite customer. I just liked him, and I liked working on his airplane. That's for sure, because he was an interesting and different kind of guy. But he had beta on his, and eventually he just like, this is not worth the money and the expense, and just got rid of them. It's like brakes are cheaper. But turbines definitely do.
You said beta range is anything from flat pitch to
Reverse.
reverse.
Flat pitch and reverse. Yeah. So while you're catching up right there, I know it's break time. But the thing I loved about this guy is, number one, he really cared about his airplane, and he was really like, I want it right. But he wasn't crazy about it. But I had to go on a test flight with him, and he was the only pilot that I would go on test flights with after a while. And I remember walking out the airplane with him, first time I was going to fly with them, and we were just talking, about what, and he goes, oh, I'm going to stop you right there. He goes, we're approaching the aircraft, and it's time for me to go into pilot mode. So if you're okay with it, he goes, I'd rather not have any conversations for a while. I'm like, I love this guy. And man, he did. He was 100% focused on the mission. We got up in the air, we got to safe altitude, and then he started talking. I'm like, Ben, you're awesome. And he goes, yeah, I go back to SimuFlight. I take refresher training in a simulator every 6 months. I mean, this guy, he was the real deal. And I'm like, man, that's the way everybody should be. So, all right, it's your break time, man.